Hello everybody, in this video we're going to look at AP CSP Topic 3.16 Simulations. Alright, let's get going. A simulation is when you take something from the real world and imitate that on the computer. If you took my class or did my labs, you did a simulation of the NBA Finals where you wrote a computer program to imitate how an NBA Finals would have turned out. Why would you run a simulation? Because a simulation can be cheaper, faster, or safer than the real thing. A simulation of the NBA Finals will run in just a few seconds instead of a week. The simulation is safer in that nobody will get hurt or tired, and cheaper in that you don't have to pay any players. Besides cheaper, faster, and safer, simulations can bring understanding by running scenarios that aren't possible in real life. For example, here is a traditional baseball or softball lineup. This is the conventional wisdom with how it should be. What happens if I do exactly the opposite? Your simulation could tell you whether this conventional wisdom is correct or not. In real life, you would never be able to do this experiment. The players would revolt. They want to protect their stats. The fans would be on your case. But with the computer simulation, you can bypass all of that to try to gain understanding about the run generating mechanisms. This all sounds so great, so you might ask, what's the catch? When you run a simulation, you get cheaper, faster, safer, and you get understanding. Unfortunately, what you don't get is accuracy. Real experiments are almost always more accurate than simulations. Why is that? Well, in every simulation, we make assumptions or simplifications. APCSP calls this concept abstraction, where we simplify all the difficult parts of the real world into something that we can program easily. For example, in our NBA simulation, we have two teams competing, and we boil everything down to the winning percentage of Team 1 relative to Team 2. But in the real world, there's a lot more to that. A player's performance depends on a lot of things. Is the person home or away? Is it late or early in the year? We abstract all of these things to a winning percentage so that the simulation is easy to program and fast to run. We could include all of these things into our simulation, but now our simulation is going to run more slowly and be harder to program. Simulations are also used all the time in science, and simplifications are used here as well. So this is a molecular dynamics simulation of an egg protein in water from the Cellular Scope YouTube channel. And here they're looking at how this protein moves. Here's another one that comes from the National Academy of Scientists. If I wanted these simulations to be 100% accurate and true to physics and chemistry, I would have to implement complicated quantum mechanics into my computer program, into my simulation, and those are super computationally intensive. My computers aren't powerful enough to run them. So what scientists end up doing is using less complicated, simplified models of how atoms interact, and we say that these are going to be good enough, or at least you hope that they are going to be good enough. And so that is the issue at the heart of all simulations. We always have some assumptions that we have to use to simplify things, and you're never 100% positive that these assumptions that you use are good enough to be accurate enough. But when they are, simulations can give you understanding, knowledge in a cheap way, quickly, and safely. So that is a quick survey of simulations, and with that, on to the questions. Question 1. A climate science team is building a simulation to predict the long-term effects of rising sea levels on coastal cities. Which of the following is the most significant benefit of using a simulation for this research? So this question is basically asking, why do we run simulations? And so the answer we're looking for here is B. Simulations allow for the exploration of potential outcomes and mitigation strategies without real-world consequences. Safe, fast, cheap, and understanding. A is wrong because simulations are not always correct. C is wrong. Simulations are usually cheaper. We could model all the variables at once if we wanted to. So the answer is B. Question 2. An agricultural company develops a simulation to determine the optimal amount of a new fertilizer to use. The simulation predicts a 30% increase in crop yield. However, an outcome is not predicted by the simulation. What is the most likely reason? So this question looks at the limitations of simulations, and that limitation is always related to the assumptions. So the answer we're looking for here is C. A is wrong because a simulation that's really complex will be more accurate, but slower. B is just wrong. An inaccurate simulation can miss in either direction. And D is wrong because the simulation was correct within its assumptions, but the assumptions just weren't good enough. So the answer is C. Question 3. This is another question about the limitations of simulations. So this simulation includes variables for birth rates, death rates, and predation rates. It does not include variables for disease or weather. Why? Well, I don't really know, but I'm assuming that disease and weather are either hard to program or they make the simulation run really slowly. This is part of the assumptions and simplifications we always make when we're making assumptions. Our answer here is C. A is not correct. We've just decided not to program these things for whatever reason. B is not correct. We could if we wanted to, just for whatever reason we have not. And D is not true. Remember, we have variables for birth rates and death rates as well. So our answer is C. Question 4. Another question basically about why simulations. So 1. It can test how the drone performs in dangerous weather conditions like a hurricane without risk. Yes, safety is definitely a good reason for running a simulation. 2. It can help identify design flaws early, saving money on materials and prototypes. These are definitely a good reason for simulations, so this is true. 3. Simulation can be used in marketing materials to show potential customers how the drone operates. This is a good reason to run a simulation, but not a traditional one. But at the same time, you don't want to turn your brain off. You want to be able to recognize that, yes, I could run a simulation, and yes, it could give me marketing materials. So the answer is all of the above, D. Question 5. Which of the following scenarios would a simulation be more beneficial than a direct experiment or calculation? So I saw a question that was like this on the AP Board's question bank. Basically, the concept here is that they want you to recognize the difference between a single isolated calculation and a simulation which has tons and tons and tons of calculations. So of these, A and C are single calculations or single simple algorithms, and B and D are ones where you would have lots and lots and lots of calculations as part of a simulation. Our answers here are B and D. Alright, so that's pretty much it. Hope that was useful to you, and if it was, please give this video a like and subscribe to my channel. I'll see you next time.